the input into that standard or that frequency on the output. That's a particularly useful function in the US market, where there is no real delineation between 60 Hz and 5994 Hz in HDMI, because it was originally developed as a consumer format for use with monitors, and monitors don't really care about that tiny little difference between 5994 and 60 Hz. It's certainly not an issue for a monitor, but in production environment it can be a real big problem. A little difference adds up and causes us all sorts of timing problems. What this enables you to do is connect your house reference up, your analog bi-level or tri-level sync, and it will automatically convert that 60 Hz HDMI input into a 5994 studio quality SDI signal. And also there's using the yellow GUI, there's a delay adjustment that you can make to time the SDI input into a switcher or router. So that's the module itself, pretty much self-contained. There are two SDI outputs, just a word. These are duplicate outputs, which means it's the same signal on both spigots. It's not left eye, right eye, link A, link B, or anything like that. These are just two copies of the same signal, and there's a cage provided on the module for an optional plug-in SFP, Fiber SFP, which comes in various different flavors, connector types, and also CWDM versions. So you've got an optional fiber output, which can be useful. Only thing, mechanical adjustment on the mechanical physical adjustment on the module is two rotary switches, which are used to set up the analog audio input, and you're basically selecting the analog channel, also the AES channel that you want to embed that analog signal into. You can go across all 8 AES channels, and you can set the input range, full scale range to line level, or you can even mute it. And again, that's the only real adjustment. Indicators on the module, obviously a power LED, audio present LED, reference present LED, and an HDMI present LED. And that's it, that's the module, self-contained. When we go to the yellow GUI application, as soon as you plug as soon as you plug the HDMI cable in, you've got the yellow GUI. Sorry, as soon as you plug the USB cable in and you've got the yellow GUI software installed, it will automatically detect the module and switch up what you see here. This part of the yellow GUI is module specific, and as you can see, the physical layout of the I/O connectors resembles exactly the module. So it gives you a very kind of easy to understand interpretation of the module's layout in terms of I/O and signal flow, which is important when we get onto the signal flow screen. This top bar is kind of common between all modules. The general settings for the modules, and I'll go through these briefly now. First thing we have on this drop down is undo or redo, self-explanatory. If you've made a setting and you undo it, or you want to redo a setting, this is where you would do it. You can import or export settings. This is nice. You can use it for backup and restoring settings, or you can use it to clone the settings into different modules. If you've made a particular setup that you'd like to use, and you've got multiple devices and you want to use the same settings, you can export those into an XML file using that function, store them away on a PC, and then you can easily import those the same way back into the module and program the module with the settings. So that's a nice way to actually clone the settings into different modules. Factory reset, extremely important function for me because I often mess things up. That will click on that and that will reset all the factory values, all the internal values is reset to factory default. If you haven't got access to the yellow GUI, there's a mechanical switch between the power connector and the fiber connector on this side of the module. You'll see a little silver Phillips screw, and underneath that is a little tiny hole, and you stick a paper clip in there, click on that, and that'll do a factory reset of the module, obviously when the power's applied, without needing to have the software running. So again, there's a factory reset, physical factory reset on the module, as well as a software factory reset. We have a locate command. What that's for is if you've got multiple modules connected to the computer, you can have multiple GUIs or multiple instances of this open. And you're not sure which one of the modules you're adjusting, you click on that, it'll flash the power LED so you can physically identify the module you're making changes to. If you've got an option code, or if there's an option that you want to enable or switch on in the module, or you've purchased a license code from us, this is where you'd enter that license code to activate that option. About this CHD, this tells you the model number, description, serial number, and firmware version. I'm simulating, so these obviously numbers are missing. But sometimes if you're talking to technical support, or we have some questions about warranty and stuff like that, we may ask you to give us this, the serial number certainly. And for technical support, we obviously will want to know the firmware revision number. That's pretty much covers the settings under this drop down. And then we got the other drop down is this one, which enables us to resize this GUI desktop site. Yeah, so currently it's at 110%. I can change the size of that. Device simulation will bring up a list of the modules that I can simulate, like I'm simulating this module. Enable local comparison. That's I'll go over that in a second. That's to do because we've got software adjustable rotary switches, and we've got physical switches, and there could be a conflict. And this is basically to deal with or manage that conflict. The most important thing, and I suggest everyone does, is the database connection. Click on here, just register with us. It doesn't take a second. All we basically need is your email address, and what that enables us to do once you've enabled or you've logged in or entered the code to register with us, is as soon as you start this application, if you're connected to the internet, immediately it will connect to our engineering servers in Germany, and if there is a software or firmware update available, a little flag will appear here on the settings tab, and you can click on that, and it will let you upgrade the firmware directly from within this software application. It will download the file and reprogram the module. It's very nice, very convenient, very easy, but you need to register to do that, and I strongly suggest that you do that. Back onto this conflict thing. As I said, you've got two ways. You can physically have these switches set to a certain position, which you can then override using these software adjustable switches here, or these settings. Now, you get this dialog come up saying, you're going to cause a problem here. The settings, the module is actually going to work different to what the physical switches are basically going to be telling you if you look at the module. So there's a conflict, and you can turn this little dialog off because it gets a bit annoying after a while. You can see now it's actually gone red, and it's telling me that there's a problem here, or not. There's a conflict, not a problem. And actually, this LED, the power LED, when this situation arrives, it actually goes red, and that tells you there's a difference between the physical switches and what's been set in software. So you actually know if you haven't got the software connected, there's something weird going on, or there's a change between this and that. And this is what this is: enable local parameters. That's what that means. And the confirm just means switching this dialog on and off. First one, I need to enable it. As soon as I enable local parameters, again, it's telling me I'm going to start overriding. Again, I get that thing up. There's all these safety layers, but you can see now I can make changes to this at will, and that LED will be red, and these switches are being ignored. So that's basically what's happening. So anyway, that covers that conflict there. We've already covered the database connection. There's only one other thing that I think is really important, certainly for me, there's a lot of settings that are possible. And these little descriptions, may be somewhat confusing. For instance, we've got SDI headroom clipping on, off. What does that mean? If you're not sure what that means, you click on what's this, click on anything, and it gives you a detailed description of what that does and how it works and what it's for. Really useful. Remember that tool. You'll need it a lot when you're going through the module to figure out what some of these settings are actually doing, because they are a bit involved and a bit technical. So again, I'm not going to go through each one and describe each one of these settings. You can do that yourself. That's not a problem. But I'll show you what settings are possible. One I will explain, because this one is important, is, as I said before, there's no image scaler inside the module. It's transparent. Whatever's on the input is converted to the corresponding SDI resolution on the output. Now, typically what would happen is there's EDID negotiation that goes on between two HDMI devices when they are connected. and that means the device sending us an HDMI signal is going to basically ask us, say, gee, what's the highest resolution that you support? And we answer back and say, well, I can go all the way up to 1080p 60. And the sending device goes, great, and it sends us a 1080p 60 signal that will correspond to a 3 gig 1080p SDI output. Now, if you're using the module in a 720p plant or some other application that isn't 3 gig capable, then obviously that's a problem. You think the module's broken because you can't see a signal, when actually the signal's there, you just can't process it because you're not 3 gig compatible. And this happens a lot, certainly with people connecting up to a lot of consumer devices, because pretty much everything does 1080p 60 now, and we're always outputting 3G, and it always causes people problems because they want a 270 megabit or they want a 1.5 gig because they're a 720p plant. Again, we don't have any way of scaling that down, so what we do is you can take it out of this automatic mode where we negotiate the highest resolution over EDID, and you can jam it. So if I'm a 720p plant, I can go 720p. Now, let's not set up a scaler. What that's done is that's basically now when the sending device inquires of the module over EDID, gee, what's the highest resolution you support, we answer back only 720p. So the sending device then scales its output to 720p, sends us a 720p signal, which we then convert to a 1.5 gig output. So that's the way you can jam the kind of operating resolution and get rid of this automatic negotiation, which can cause problems in some applications. And this is only settable in Yellow GUI. Obviously, it's automatic is the way it's delivered out the box. That's the factory standard, or factory reset is automatic mode. You'd have to go in and make that change manually. Another thing that happens is if you do ever change any of the internal settings away from the factory reset values, this LED turns an amber or yellow color. So what it's letting you know physically on the module is there's some internal settings within the module in software that are different, that I may not be aware of. I'm certainly not aware of, that are different to factory standards. If the module's doing something stupid again, or if you don't understand what's going on, and you see an amber LED there, you can connect up the software and do a factory reset or see what's different. Or you can connect that little factory reset button in through the hole, and that will reset the module back to factory, and the LED will turn back to green. So there are 3 states for this LED: green, which is normal and power present. You've got yellow, which is power present and an internal software setting has been made, and you've got red, which basically says you're overriding some mechanical setting on the module. Alright, so it's important to understand the 3 states of this LED. So again, these are all the video commands that are available: output resolution, color range, between auto, limited or full color range, whether you want to do level A or level B dual link in terms of the 3G output, limit the video standards to full list or limited list. Quickly, that one means that HDMI can obviously support a whole plethora of different resolutions. That's the full list of possible resolutions. Or there's limited, which means it's limited to video size HDMI signals, like 720p, 1080p, things like that. SDI headroom clipping, HDMI input range, limited, automatic or full. Again, if you need more information on any of these, use the watch this thing, and it will give you a description of what that is and what that's used for. We work our way across the tabs at the top here to see what we can do. Obviously they're the video adjustments. Now we go to audio adjustments, and again we can set the bit depth 2024 bit, audio channels 1:1 or convert. Again, that's a little bit involved, this conversion. So you go, what's this? What does that mean? And it means that they're remapping the audio channels per some SMPTE standard. Alright, so that tells you precisely what it's doing. Keep that on 1:1. And then embed the audio, 3G level B audio into what stream? Stream A and stream B, or stream A only, stream B only. Again, that's if you're in 3G level B mode. That would be important adjustment. For delay, this is nice. This obviously, as I said before, if you've got a reference connected, you can then delay the SDI output up to a full frame, and that's adjustable in lines and pixels. And because it's one full frame, the adjustment is technically infinite, and you can do it here. You can adjust the lines or pixels up and down to time it, or you can just enter it in milliseconds. You enter the delay as a time period. So that would be the delay adjustment. Then we've got metadata. We can enable AFB embedding, video indexing, metadata on or off. For our European friends, widescreen signaling enable, again, that metadata on, off, or auto. And level B, whether it's dual stream or stereoscopic mode. Expert mode, accept encoded audio off and on. What that means is HDMI can sometimes have AC3 or Dolby Digital audio. What we're basically saying is we can either accept that. If we switch that on, then when the EDID is communicating with the sending device, we're going to answer back, yes, send me AC3 if you've got it, or send me Dolby Digital if you've got it, or whatever the encoded format is. We will accept it. Now what we do is we accept that, and we basically then re-embed that encoded audio into the SDI stream, unprocessed, unmolested. We don't decode it, re-encode it, we don't convert it. It's just the AC3 audio will be on the corresponding AES channel embedded into the SDI. Now sometimes people have called me up and says, gee, my module's not working, all I can hear is this digital mush on the audio channels. And the reason for that is because they've got this set to on, and the sending device is sending them AC3. The AC3 is being funneled through the embedder and embedded into the AES output unprocessed. So you're listening to digital noise, which is the encoded audio. If you switch this to off, what happens is EDID answers back to the sending device, no, I can't process AC3, Dolby Digital, or any encoded audio format. Only send me PCM. Then the sending device will send PCM audio, and then that'll be embedded as PCM audio in the output. So this is basically an on-off switch for accepting or not accepting encoded audio. Force free run is basically ignore the sync obviously if there's a physical, if the sync is connected, it will automatically convert the HDMI signal and frequency lock it to the reference. You can tell the module, without physically taking the cable off the module, you can basically tell it to free run without with the signal connected, i.e. it's disconnecting this sync internally from the frame synchronizer. Okay, so that covers all the tabs. One other thing I didn't mention, there is the status is always displayed at the top here. SDI output status, you can see the reference lock is in free run, because I've just set it free run. 3G format is level A, again that would be level B if the output was set to level B or whatever. HDR input detected mode is a DVI input, it's RGB limited signal, 8-bit, and audio is a stereo signal. Again, this would change depending on the input connected, and this would change depending on how you configured the output. Obviously, it automatically will configure itself to match this input resolution. But obviously, as you can see, you can make a lot of changes to that here. One other nice thing is our signal layout. Again, this is where the physical layout of the module is nice, because you can actually see the signal flow through the module. And I'll briefly explain that. As you can see, you've got the HDMI input here, and you see it's the big kind of yellow line. You can see it goes in here through the frame synchronizer. It's obviously frame synchronized using the reference input, and the reference input also goes to synchronize the audio, and then the video comes out to these three outputs. You've got the two SDI, or actually basically three SDI outputs, two are copper, one is fiber, with its optional fiber SFP. The audio is also synchronized. Now, important thing about when the frame synchronizer may be dropping and adding a lot of frames and chopping things in and out, to maintain frequency lock, you don't need to worry about the audio. As I said, the frame sync is really sophisticated. There'll be no pops or clicks to the audio whatsoever, even though we may be dropping frames like crazy. So the audio will go through unmolested and completely clean. And also the audio is delayed to match the video. So if you've set a manual delay up, the audio is obviously delayed to match that. And again, as we're chopping frames out or adding frames into frequency lock to the reference, obviously the audio timing is maintained. You're not going to get a drift of audio timing and lip sync problems or anything like that. that's all taken care of. HDMI only supports 8 channels of audio, so you can see there's only 8 channels coming down into the embedder for the SDI output, and we take all 8 channels. You can see the analog audio input is here, and you can see that's routed into group 4, so we've taken all 8 channels from the HDMI input, we've basically embedded that into group 1 and group 2 of the SDI output, and we've embedded the audio into group 4. Again, this is where you would change it, so I wanted to put it into AES1. You can see this now, I've routed the analog audio into 1 and 2, effectively overwriting channels 1 and 2 are being ignored now, because I'm overwriting them with the analog audio input. And what you would do is you would select the channel that you want to inject that analog audio into, if you want to at all. A lot of the times you don't need to do that. So you can just ignore those audio, and if there's no audio present, this wouldn't be lit up anyway, so this is obviously showing audio present, so it's lit them up, and you can see where you're embedding those. This again is sample rate converters. They're on and off typically, with encoded audio, as I mentioned before, with AC3 and Dolby Digital and any encoded audio format. You do not want to sample rate convert those audio streams, because they will be destroyed. Typically PCM audio does go through a sample rate converter for the purposes of locking the audio. So that basically covers the module. As you can see, it's a very useful tool to configure the module. Important thing to remember again is this LED. It always tells you what's going on. Green means good. Amber means some settings have been made internally, so it might not be doing what you think it should be doing. And red means there's a difference between these physical switches and what's set in software. Aside from that, that pretty much covers the yellow GUI and the operation of this module. One last thing I'd like to mention is go back to the device simulation mode. You can see these are all the yellow bricks which can be simulated, and I'm simulating this module for the purposes of the tutorial. But as you can see, I could quite easily select another module and it will switch it over, and just for the purpose of showing you how this works, now you can see I'm now simulating an analog audio embed at a PDM1383. That module's actually got a dip switch on it, so again you can see I could now override those dip switch settings using the software, and again the LED would be red and would be warned and all this other kind of good stuff. You can see here the signal routing is a little bit more sophisticated on this module. We can actually drag and drop the audio using the graphic user interface here, and we've got a metadata tab. I won't get into this module. There'll be I'll make another video for this module to describe its function eventually. I just wanted to show you that there are a number of different modules that you can freely simulate without having to actually own our modules. You can download this software for free from our website. Go to support, downloads, yellow GUI software, and just download the software application. We have a version that's compatible with Windows, and we also have a version that's compatible with a Mac. So you can download either version, and when you download it, you can switch. We don't have to register, you don't have to give us email addresses, you don't have to do anything. You can just go grab it for free, install it and run it. So it's a nice little tool. Lets you see a lot of the power of the module that's very difficult to describe in a catalogue or a spec sheet. Sometimes it's just a fun go through all these different settings. You can see what the module can and cannot do. So the next slide will show you links to our websites, our 2 main websites, where you can get more information on the yellow brick module, and in particular this CHD 1812, and also you'll be able to get information on yellow GUI and download the software. So I thank you for your time.
This is an ad for a project management tool called Monday.com. This is what it looks like, and this is what it feels like. So the tool works like this. We call this a board. Just put everything you need to do here, then put who's in charge of it here, and see where everything stands here. Also, it works on your phone because it's 2019. Click drag and drop to create your board exactly the way you need it. You'll never drop the ball on the important stuff again. So go to monday.com and create your free account today.
introduce the CHD1812-1 HDMI to SDI yellow brick converter. This is one of the more popular modules from Questek, and it's one of the more sophisticated devices we have because it has an integrated frame synchronizer. You can see on the video that I have put the physical picture of the module one side and the yellow GUI software application that can be used with the module when connected up by the USB cable. The module is pretty much self-contained, pretty much plug and play, and for 90% of the applications you wouldn't necessarily need to use the software. It will automatically detect the HDMI input and give you a corresponding SDI output. Some examples: if you connect a 625 or 525 HDMI input, it will give you a 270 megabit SDI output. If you give it 720p or 1080i, it'll do a conversion and give you a 1.5 gig SDI output in the same format. If you give it 1080p signal, it will give you a 3 gig output. There is no scaler inside this module. It's a transparent conversion, same format on the output as is on the input. There is a reference input for the frame synchronizer. It's a very sophisticated frame synchronizer, and it's capable of cross-locking. What that means is it's even possible for you to put a 50 Hz input on the HDMI and give a 5994 reference, and it will actually give you a 5994 output. That's the way the module works, is that you're a slave to the reference input. The purpose of this tutorial is to briefly introduce the CHD1812-1 HDMI to SDI yellow brick converter. This is one of the more popular modules from Questek, and it's one of the more sophisticated devices we have because it has an integrated frame synchronizer. You can see on the video that I have put the purpose of this tutorial is to briefly introduce the CHD1812-1 HDMI to SDI yellow brick converter. This is one of the more popular modules from Questek, and it's one of the more sophisticated devices we have because it has an integrated frame synchronizer. You can see on the video that I have put the physical picture of the module one side and the yellow GUI software application that can be used with the module when connected up by the USB cable. The module is pretty much
Hi, I'm Jordan from Kettner Creative, and in this video I want to show you how to set up a small basic sound system. A lot of the things that we go through in this video, hopefully it's short, are also applicable into large events as well.
Hi, my name is James Merchant. I'm one of the sales managers from Questek, a German company, and we are manufacturers for the yellow brick product range. I want to show you one of our newest products, which is the CDH1813. This is the follow-up module and the big brother of the CDH1811. Effectively, it is an SDI to HDMI converter. The previous model was already very successful and still is very successful, and this one we have now added 3D functionality, and from the previous model you may already know that it has various burn-in features for the HDMI output which are really useful for monitoring the SDI input signal, and here we've added more features. So now we've also got safe area markers in there as well. We can also do the horizontal and vertical flip for monitoring the blanking intervals, and also this model now also has 3D support, so you can actually take a 3G level B signal with a 3D input in there, and you can convert it to side by side or top over bottom, and you can also flip the input signals. Now, as you know, it sounds quite a lot because it's got a couple of controls over here, so it's pretty difficult to control everything I just said over those things. So that's why we now have the yellow GUI, which gives you access via the USB connector to the more detailed setup of these individual modules. So now you can actually do things like you've got the safe area markers, and you can actually define the safe area markers, what you want to see there, if it's 16:9, 4:3, if you've got aspect ratio markers, if you want to have the curtain transparency, and these sort of things. So you can really go into great depth of the setup of the module, and also from the HDMI setup you can also set the bit depth and all those sort of things. So it's got much more access to the module than it used to have from the local control, and that will give you great new tools and new features to these modules. That's pretty much it. Thank you for listening. My name is James Merchant from Links Technic.
Let's suppose that you're writing a really important email to a colleague, or a post on Facebook that all your friends will see.
This one? Guitar players.
Okay. 1, 2, 3. Jump!
sorry, I was making video. I don't even understand most of the Spanish. I only know one final the rest, remember the guy who translated.
That's a joking story. What's the joking story? That is a cold joke.
Sorry, I didn't hear it.
We lost the ticket if you know what it is.
There we go.
Beton en staal in het gebouw zat dan op de tekening stond.